Hello everyone, I am Dr. P. Kumari, working as an Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Today in this video, I am going to discuss about question bank of Module 4. So what is the Module 4 here? Vector differentiation. So here already we discussed about the vector differentiation in some of the videos. So for about the content, you can go through that videos, and after then you can check about the question bank questions. First of all, what are the definitions we are having in the module 4? We can discuss here. So vector differential operator, this is the important thing in the vector differentiation. So this is the operator we are using in our problems. So what is the vector differential operator? So this one is called it as del. So del equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So here we are having a gradient of the scalar function. That definition you can see here. Grad pi equal to del pi, nothing but that is the I into dou pi by dou x and j into dou pi by dou y plus k into dou pi by dou z. So here, if this gradient value, so this will become as a vector value. When you are using this gradient of the scalar function, we are going to get the vector here, because here we are going to get the ijk. So next you can observe here about the directional derivative. What is the directional derivative? Directional derivative formula is here, that is del pi dot e. Otherwise you can denote this one as a d also, del pi dot d. Otherwise del pi dot a cap. What is this a cap? Is a by det of a. So this is the definition or formula for the directional derivative. So here what is the gradient of the scalar function? Already we observed in the before. So gradient of the scalar function is nothing but del pi, that is I into dou pi by dou x plus j into dou pi by dou y and k into dou pi by dou z. And what some of the properties we are going to use in the problems also you have to remember here. So here if f and g are the two scalar functions, we can write this form, that is grad f plus or minus g equal to grad f plus or minus grad g. And the necessary and sufficient condition for the scalar point function to be constant is that is del pi equal to, del f equal to 0. So here one more formula is there, that is grad of fg equal to f into grad g plus g into grad f. And one more information you can see here, that is c is a constant, grad cf equal to c grad f. So these are the forms we are going to use in the question bank question, that is in the module 4. And here some more topics also is, that is one is the divergence. What is the divergence? How we can apply this divergence for the vector? So suppose let f equal to f1i plus f2j plus f3k, then we can calculate the divergence f, that is del dot f. So here we are using the dot product. Already we know about the del. What is the del? I into dou by dou x plus j into dou by dou y and k into dou by dou z, and dot f1i plus f2j plus f3k. So when you are doing the dot product here, already we know the values of this. I dot I is 1, j dot j is 1 and k dot k is 1. By using that we are writing here dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So directly divergence f, otherwise del dot f value is formula is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. If this divergence value or det value is 0, we can say that this function is solenoidal. This function is solenoidal. You should remember this definitions, because in some of the equation directly they will give the given function is solenoid. So if it is solenoidal means what is that? That det value, divergence value is 0. Dot product value is 0. That you have to remember. And here one more definition also we need, that is curly f, that is del cross f. Del cross f means we are doing the det value here, that is I j k dou by dou x dou by dou y. So what is this dou by dou x, dou by dou y and dou by dou z? This is the del operator form. Del equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So that's why first we are writing the coefficients of I, J, K for the del. So dou by dou x, dou by dou y and dou by dou z. And here the f, so f1, f2, f3. Now we are doing the dead value. So this value is I into this cross product we have to take, except the first row and first column. So dou f3 by dou y minus dou f2 by dou z. So this is the first one. After that minus j into. So now we have to take the value. We accept the middle row and first row and middle column. So then we have to do the cross product. Dou f3 by dou x minus dou f1 by dou z. Next plus k into now we are going to take about the third one. So third column and first row, except those values we are taking here. Dou f2 by dou x minus dou f1 by dou y. So this is the formula for the dead value. So if they are asking the problem to calculate the curl value, we have to use this one. If they are asking to find out the divergence of that vector function, we have to use this formula. And before, if divergence value is 0, that we can call it as solenoidal. If curl f is 0, that function is irrotational. In the problem, if they are asking this is irrotational, means directly we can write that curl f value is 0. So see here, in the question bank, we are having three parts. Part A and Part B and Part C. In the Part A, we are having the problem solving and critical thinking questions, and Part B, we are having long answer type questions and C short answers. So first we are going to discuss about Part A here. So here see the first problem. Find the angle between the surfaces. What are the surfaces they given? X square plus y square plus z square equal to 9, and here x square plus y square minus z equal to 3. So these are the two surfaces at the point. What is the point they given here? That is 2 comma minus 1 comma 2. So at this point, so what we have to find out? So we have to find out the angle between these two surfaces. First of all, what is the formula for the angle? To find out the angle, then if you know that formula, we can calculate or we can find out this value. So here angle between the surfaces are normals. We are using the formula cos theta equal to n1 dot n2 by det of n1 into det of n2. This is the formula. So otherwise A dot B by det of AB and det of B. So what is the n1? N1 is the unit normal for the first surface. What is the n2? N2 is the unit normal for the second surface. What is the n1 here? So what is the function we are going to take here? Del pi by det of del pi. This is the n1 value. N2 is, so here also del pi det of del pi. This is the n2. So we can calculate here to find out the angle. So first of all, we have to calculate the n1 value. We need the first surface, first one. So first surface they given, we are taking this one as a pi or f. So this one is x square plus y square plus z square minus 9. So we have to calculate the del pi value. So how to calculate del pi? Del pi formula is I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So we should know about the partial differentiation, then only we can know about the grad pi. So first of all, dou pi by dou x. So dou by dou x of, what is the pi value here? That is x square plus y square plus z square minus 9. So here derivative of x square is 2x. So y square is 0, z square is 0 because these are the constants. So this one also constant. So first one is 2x. Next one is dou pi by dou y. That is dou by dou y of x square plus y square plus z square minus 9. No, now this value first term is 0 constant, second term is 2y, and third term and fourth term also 0. So finally this value is 2y. Next, dou pi by dou z, that is equal to dou by dou z of x square plus y square plus z square minus 9. So now dou by dou z of, so first term is 0 and second term also 0 and third term is 2z. So now here we are writing the del pi value. Del pi equal to I into dou pi by dou x value is 2x plus j into dou pi by dou y value is 2y plus k into dou pi by dou z value is 2z. This is the del pi value. So here to calculate the n1, I need del pi by det of del pi. So here at the point they given, what is at the point 2 comma minus 1 comma 2. So del pi at the point 2 comma minus 1 comma 2 we have to calculate. So that means in place of x, y, z we need to replace these values. So I into 2 into 2 plus, so j into 2 into minus 1 plus k into 2 into 2. So finally what is this value for the del pi 1 equal to 4i minus 2j plus 4k. This is the n1 value. This is the n1 value. What about the n2 value? So now we have to take the second surface. In the same way we have to calculate the del pi value. After then n2 value. So n2 value is del pi 2 by det of del pi. So here n1 value we are calculating 4i minus 2j plus 4k by square root of 4 square is 16 plus 4 plus 1. So we can calculate n1. So we can calculate similarly, we can calculate n2 in the same way. Then we can find the cos theta value, that is n1 dot n2 by det of n1 n into det of n2. So next see the second problem. Find the angle between the normals to the surface x square equal to yz at the points 1 comma 1 comma 1 and 2 comma 4 comma 1. So here before they given two surfaces and given the one point. In this problem they given only one surface, they given the different points. That means here we know the formula to find out the angle, that is cos theta equal to n1 dot n2 by det of n1 into det of n2. So here we can write this one as a n1 means we are going to calculate the del pi value at the first point. At the first point is n1 and we can calculate same surface value at the second point is n2. That means first we can calculate the del pi value. First of all, what is the pi here? Given surface is x square minus yz. So here del pi equal to, here del pi value, here we are calculating I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So here first of all already we know the pi, right? So dou pi by dou x. So that means x square is 2x. Next dou pi by dou y. So x square is constant 0 minus z into y is 1. Next dou pi by dou z is equal to x square is 0 minus z into y into z value is 1. So dou pi by dou x is 2x, here minus z minus y. I can replace here to get the del pi. So I into 2x plus j into minus z plus k into minus y. So finally this is 2x into I minus z into j minus y into k. So 2 into at the point 1 comma 1 comma 1. So that means 2 into 1 into I minus 1 into j minus 1 into k. So finally this is 2i minus j minus k. This is the n1 value. So in the same way we are going to calculate, this is the del pi value at the first point. So that means n1 equal to del pi 1 by det of del pi 1. So this is the n1 value. So based on this, that is 2i minus j minus k by square root of, here the quotient square terms, 2 square is 4, 1 square plus 1 square. So this one is root 6. This is the n1 value. So similarly we can calculate the n2 value. After then we can substitute here in the formula to get the theta value. So see the third one. So divergence of grad r power m is equal to m into m plus 1 into r power m minus 2. Here we need to prove this one by using the r, that is xi plus yj plus zk. Xi plus yj plus zk. So for this type of proofs or problems, we need to use the r value, that is xi plus yj plus zk, and r square equal to x square plus y square plus z square. So what we have to prove? Divergence of grad r power m is equal to m into m plus 1 into r power m minus 2. So here first we have to calculate grad r power m. After then we can calculate the divergence. So here first of all we should calculate the sum of the terms from the r square. Now differentiate the r square with respect to x, y and z. So if you are doing with respect to x, this is 2r into respect to x, we are doing dou r by dou x equal to x square is 2x, remaining 2 are constants. So finally dou r by dou x value becomes x by r. Similarly dou r by dou y value is y by r, and dou r by dou z value is z by r. We are going to use these three values in the proof. Now first we want grad r power m, that means del r power m. So what is the del value? I into dou by dou x of r power m plus j into dou by dou y of r power m plus k into dou by dou z of r power m. So here I into dou by dou x of r power m means m into r power m minus 1 into dou r by dou x. In the same way remaining also we are getting j into, so here I. So first term we are getting I plus, and here also m into r power m minus 1 into dou r by dou y into j, plus here also k into dou r by dou z into m into r power m minus 1. So here m into r power m minus 1. So dou r by dou x value is x by r into I, plus here y by r into j, plus z by r into k. So taking the r also common again, m into r power, already m minus 1 is there. This is the 1 by r. So take the common r power minus 1. So xi plus yj plus zk. So this is m into r power m minus 2. So here we are getting this value is r. So finally m into r power m minus 2 into r power minus 1. So r power minus 1 means we can get here minus 1 and minus 1 is minus 2, and this one is r bar. So this is the grad r power m value. So for this we are going to use the divergence, then we can get the final value here. See the fourth one, we show that the vector, so this is the vector, is irrotational and find its scalar potential function. So here we have to show this vector as a irrotational. So that means, what is the definition of the irrotational? Curl f bar is 0. Then we can say that that is the irrotational. So we can say that that is the irrotational. So curl f value 0, then we can say that this is the irrotational. So that means we have to find out the curl f value, and we should take is equal to 0. That means what is the curl f here? So first we have to write what are the functions we are having here. So f equal to x square minus yz into I plus y square minus zx into j plus z square minus xy into k. So here first we are taking curl f is equal to 0, that is equal to ijk and dou by dou x, dou by dou y and dou by dou z. And what is the I coefficient? X square minus yz. And what is the z coefficient? J here. Dou by dou y square minus zx. What is the k coefficient? Dou by dou z square minus xy. So here this is equal to 0. So this value we have to calculate. Then we are going to equate to 0. Then we can say that we can show that. So we have to get 0. Then we can say that that is the irrotational. That means first we have to calculate the curl F value. That should be 0. Then only this will be irrotational. So after getting this is irrotational, then only we can find the scalar potential function. If curl F is not equal to 0, then you should not get the scalar potential function. So that means you should get curl F value equal to 0. So then only you can find the scalar potential function. So the next one, determine the unit vector normal to the surface x y cube z square equal to 4 at the point minus 1 comma minus 1 comma 2. So here this is the pi. We can write pi equal to x y cube and z square minus 4. So we have to calculate the unit normal. What is the unit normal? N equal to del pi by det of del pi. That means we have to calculate the del pi value by using the formula dou by dou x plus j into dou pi by dou y plus k into dou pi by dou z. After that we can replace here n equal to del pi by det of del pi. Then we can find the unit normal for the given surface at the point minus 1 comma minus 1 comma 2. And see the sixth one, find the directional derivative of the pi at the point 1 comma minus 2 comma minus 1 in the direction of normal to the surface x log z minus y square at the point minus 1 comma 2 comma 1. So here what they are asking to find the directional derivative. Directional derivative formula is del pi dot a cap. So here we have to know about the del pi value and we should know about the a cap. A cap is a by det of a bar by det of a bar. So we should know about the vector and we should know about the del pi. Already pi is given. So del pi, so del of x square yz plus 4xz square. So here we are going to find this del pi value at the point 1 comma minus 2 comma minus 1. After that we should get the a cap, that is vector. So how we can get that normal? So by using this f function. So here by using this f function at the point minus 1 comma 2 comma 1, so we are going to get the a cap vector. So then directly you can calculate directional derivative by using the del pi value on a cap. So del pi dot a cap. So finally this is the directional derivative. And see here, prove that. See the seventh one, what they are asking, prove that del r power n equal to n into r power n minus 1 into r bar. So here del r power n value should be equal to n into r power n minus 1 into r bar. So what is the del meaning? I into dou by dou x plus j into dou by dou y plus k into dou by dou z into r power n. That means I dou by dou x of r power n plus j dou by dou y of r power n plus k dou by dou z of r power n. So now here I into dou by dou x of r power n means n into r power n minus 1 and dou r by dou x plus the same way here also j into n into r power n minus 1. So remaining is j into dou r by dou y. In the same way for the third term also, k into n into r power n minus 1 by dou r by dou z. So into k. So now here n into r power n minus 1. So already we calculated in the previous problem you observed, right? So what is that value? For this type of proofs we need r square value and r value. R value is xi plus yj plus zk. So what is r square value? X square plus y square plus z square. So now we are writing here 2r into dou r by dou x is equal to 2x. So finally dou r by dou x value is x by r. So similarly dou r by dou y value is y by r and dou r by dou z value is z by r. So we are using these values. So x by r into I plus y by r into j plus z by r into k. So now so n into r power n minus 1, one more r power n minus 1. So xi plus yj plus zk. So finally this is n into r power n minus 2 into r bar into r bar. So this is the flow. This is the flow. So here also in the same way for the eighth one, if they are asking to show this type of proofs, we have to use del of f of r. Here we should use r value is xi plus yj plus zk and r square equal to x square plus y square plus z square. So when you are calculating here, dou r by dou x value is x by r and dou r by dou y value is y by r and dou r by dou z is z by r. We are going to use all these terms in the simplification to get the value like this for the del of f of r equal to f of r by r. See this one, ninth one. Find the directional derivative of the given function. What is that function? Phi equal to xy square plus yz square plus zx square along the tangent of the curve. So that we are taking here x equal to t and y equal to t square and z equal to t cube at the point 1 comma 1 comma 1. So here for the vector that a bar xi plus yj plus zk. So here for the vector we are going to use this curve, tangent curve, and for the del phi we are going to use this one to calculate the del phi. So what is the formula for the directional derivative? That is del phi dot e, otherwise del phi dot a cap. So you get a cap from the given curve and you can get the del phi from the function. So finally when you are doing the dot product you can get the directional derivative. And let's see the 10th question. So if the temperature at the point in a space, what is the temperature they given? T equal to xy plus yz plus zx. Find the direction in which the temperature changes most rapidly with the distance from the point and determine the maximum rate of change. First of all, we have to do this one. Dou t by det value you have to find. So after then at the point we can find out the maximum rate. So first of all, so this is t equal to xy plus yz plus zx. So we are going to calculate del t value. So that means gradient of t. So I into dou by dou x of xy plus yz plus zx. We are going to use this summation. Then ijk we can write. So first of all, dou by dou x of xy plus yz plus zx value we have to calculate. So with respect to x we are doing, y is the constant, so x is 1. Plus here y and z both are constants, so 0 plus z into x value is 1. So finally, first with respect to x, the t value dou t by dou x is y plus z. In the same way, dou by dou y of t. So that is, here x is the constant, y is 1. Plus z is the constant, y is 1. Plus here z and x both are constant, so 0. This is x plus z. In the same way, we are doing with respect to z also. So that is, here with z, so first x and y both are constant, 0. So y into z value is 1. plus here x into z value is 1. So finally we are getting here x plus y. So y plus z, x plus z, x plus y. So we are going to replace here. So that is del t. So del t equal to, we are getting the value. So finally maximum rate is det of del t value. So here det of del t value. So when you are calculating del t value is nothing but the maximum rate of change. And see the part B. So part B is long answer questions. So what are the long answer questions we are having? You can see here. See the first question. If vector field is irrotational, find the constants. So here actually what is the definition for the irrotational? Irrotational means curl f bar E should be 0. So then only you can say that irrotational. That means here for the f, so curl f equal to 0. So first we have to calculate I, j, k. So del value is dou by dou x, dou by dou y and dou by dou z. And here we are having I, j, k coefficient. So x plus 2y plus az and vx minus 3y minus z. And here 4x plus cy plus 2z. So this test value should be 0. So that means in the problem one they are telling that this is the rotation. That means we can equate to 0. So after calculating this value, we are going to equate to 0 to get the A, B, C values. A, B, C values. So in the same way we can observe here for the second problem. Find the constants A and B for the surface ax square minus byz equal to a plus 2 into x will be orthogonal to the surface, these two surfaces. So orthogonal means we have to take here this one as a first normals, we have to find unit normals. After then we can calculate the constants by using the condition of the orthogonal surfaces. So see the third one, show that this function is solenoid. Solenoidal means what is the definition you should know. Solenoidal definition is divergence of that function. So divergence of A should be 0. Then we can say that that is that solenoidal. So here already A is there. So divergence formula we have to use. That is dou A by dou X plus dou A by dou Y plus dou A by dou Z should be 0. Then we can say that this is the solenoidal. In the same way for the fourth one also. So here they are asking to prove this is the rotational. After then find the scalar function. So you have to show this one curl f bar or curl a bar should be 0. Then this is irrotational. Then this is irrotational. If it is 0, then only you can say that this is the rotational. After then only you can find the scalar potential function. So after that we can calculate the scalar potential by value. And here if del pi equal to this value, find f value and f of 1, 0, 1 equal to 0. So before all problems they given f value and asking to calculate del pi value. Now they given reverse. So they given del pi value, del f value. From that you are going to find the f value. So here if you know that, so del f is this function. So reversely you can calculate the f value. After then we can substitute x, y, z. Then it is going to show the 8. So now see this, find the curl of v. So here e power x y z into I plus j plus k at the point 1, 2, 3. So here we have to find the curl v. So given v function is e power x y z into I plus e power x y z into j plus e power x y z into k. So curl f means we have to calculate the det value. So del is dou by dou x, dou by dou y and dou by dou z. And here values are e power x y z. The same way e power x y z and e power x y z. When you are calculating the det value, then after then we can substitute the point 1 to 1, 2, 3. So here see the seventh one. If f of r is differentiable and r value is x square plus y square plus z square whole power 1 by 2. Then show that f of r into r bar is irrotational. By using this r value, we have to calculate f of r into r bar, and that should be equal to 0. So then only we can say that this f of r into r bar is irrotational. And see the eighth one. So f function is given and g function is given. So we can calculate del of del f dot del g. That means from the f we can calculate the del f value. From the g we can calculate the del g value. That means grad f, and here grad g. You know the formula for the grad, right? So del f equal to I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. In the same way, we can use for the g. After then, we can do the dot product, and again we have to apply the del value. Then we can get the final value. See here, find the angle of intersection of the spheres, the given spheres here. So we have to calculate the angle for these two surfaces. What is that angle? Cos theta equal to n1 dot n2 by det of n1 into det of n2 at the point 4 comma minus 3 comma 2. So for this point, we have to calculate the n1 value for the first surface and n2 value for the second surface. After then we can calculate the angle. And here also in the same way, we have to calculate the angle value by using the formula, but here only they given one surface. You have to use the 2 points here. Before, two surfaces 1 point, here 2 points for the one surface. And here also in the same way, first we have to calculate the n1 and n2 for the function, that is 2x square plus 3y square minus 5z for the first point. So that is 2 comma minus 2 comma 4. We are going to get n1 value. For the second point, that is 1 comma minus 1 comma minus 1 comma 1. From this we are going to get the n2 value. By using these two, we can calculate the cos theta, that is n1 dot n2 by det of n1 dot det of n2. So here find the directional derivative for the function pi, and in the direction of 1 comma minus 2 comma minus 1. So here a bar is I minus 2j minus k, and from this we can calculate a cap, that is a bar by det of a bar, and calculate the directional derivative, that is del pi dot a cap. So a cap is already we know. So we have to calculate this del pi value from the pi, that is xy square plus yz cube. So what is the del pi value? That is I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So by these two values we can calculate the directional derivative. So see the 13th problem. So determine the constants here by is showing it is the irrotational, and find the scalar function. So here curl a bar should be 0, then only we can say that that is the irrotational. So already they given this is the rotational. That means you have to use this condition to calculate the ABC values. That means det of I, J, K, and dou by dou x, dou by dou y, and dou by dou z, and here 2x plus 3y plus az, and j coefficient and k coefficient. Finally, this is equal to 0. Then we can find the ABC values from the det value. So here determine the curl of this function. In the same way, here we can use the det product for the xy square, xyz square, and yz x square, and zxy square we can write here, and in place of del dou by dou x, dou by dou y, and dou by dou z at the point 1 comma 2 comma 3. And see here, find the value. So value of b, that constant, such that this a bar has its curl identically equal to 0. So curl identically equal to 0 means this is irrotational. This is irrotational. So in the same way, det value we are going to equate to 0. I, j, k, dou by dou x, and dou by dou y, and dou by dou z. We are writing the I coefficient, j coefficient, and k coefficient. We are getting here equal to 0 to get the value of b from this. So here F bar is given, that is r power n into r bar. We are going to calculate the divergence F bar. So here, if divergence F bar is 0, then we need to calculate the n value also. That means first we have to calculate divergence F, that is dou F1 by dou x plus dou F2 by dou y plus dou F3 by dou z. This value first we have to calculate. After then we can equate to 0 to get the n value. So see here, if A and B and C values are given, we have to prove grad A, grad B and grad C is equal to 0. So that means from the A value x plus y plus z, we have to calculate grad A. We have to calculate grad A. From the B value, we are going to calculate grad B. Grad B. And from the C value, we are going to calculate grad C. So after getting all these grad A, grad B, grad C, we have to calculate the debt value of that. That is, we are going to show as a 0. See this, prove that this is a both solenoidal and irrotational. That means we have to calculate the divergence F. If you are taking this one as a F, so divergence F we have to calculate, and curl F also we have to calculate. That is dou F1 by dou x plus dou F2 by dou y plus dou F3 by dou z we have to calculate. That is, if you are getting 0, then we can say that this is the solenoidal. This is the solenoidal. So you have to take here curl F, that is the debt value you have to calculate I, j, k. So dou by dou x, dou by dou y and dou by dou z. We have to write the quotients of x, y and z. This if you are getting 0, so we can say that this is the irrotational. And see this, find the directional derivative. Del dot del f at the point 1 comma minus 2 comma 1 in the direction of the normal. So here we are going to get a cap from the normal, that is x y square z plus 3x equal to 3x plus z square. So from this we are going to calculate the unit normal, and after then we can calculate the directional derivative, that is del pi dot a cap. So a cap equal to a bar by det of a bar, and after then we can calculate the del pi value from the given surface. So then after getting del pi value and a cap, we can do the dot product to get the directional derivative. Here see, calculate del square f. What we have to calculate here? Del square f. So f we know. So first we can calculate del f value. After then del square f value at the point 1 comma 0. Then finally you can get del square value at the point 1 comma 0. So this is the way to solve the problems by using the formulas of the divergence, curl and gradient. So here in the vector differentiation, you should know the formulas and definitions properly, then only you can calculate it. So you can go through these problems, and for the basic formulas and solutions, please refer these textbooks. Higher Engineering Mathematics written by S. Gravel, and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Higher Engineering Mathematics written by B.V. Ramana, and one more is there Engineering Mathematics written by T.K.V. Iyengar. So these are the textbooks you can use to refer the vector differentiation problems and for the definitions and formulas also. I hope you understand about the discussion of a question bank of vector differentiation. Thanks for patience.
Like, share and subscribe. Hit the bell icon for more updates.